day everyone. This video tutorial will help you know many things about OSPF. So, let me first define what is OSPF. OSPF is a link state routing protocol that was developed as a replacement for the Distance Vector Routing Protocol, Routing Information Protocol, or the RIP. It is used to determine the correct route for packets within IP networks. It was designed by the Internet Engineering Task Force to serve as an interior gateway protocol replacing RIP. Features. An OSPF has the following features. First, it is effectively loop-free, having a maximum hop metric of 65,535. It can load balance network traffic between multiple paths of the same metric value. It supports authentication using passwords and other methods. It converges quicker than RIP, since routing updates are sent immediately instead of periodically. It uses less bandwidth since transmission takes place only when routing changes occurs. It supports the logical grouping of network segments into areas. It announces routes outside of an autonomous system within the autonomous system so that it can calculate cost to reach outside networks. Since OSPF announces subnet mask, it supports CIDR, or the classless interdomain routing, VLSM, variable length subnet mask, and supernetting, used to aggregate Class C network and non-contiguous network segments. Five types of OSPF. There are 5 types of OSPFs, and these are the following. 1. Hello packets. Hello packets are used to establish and maintain adjacency within other OSPF routers. Second, the database description. The database description packet contains an abbreviated list of sending routers' link state database and is used by receiving routers to check against the local link state database. 3. The link state request. Receiving routers can then request more information about any entry in the database description by sending a link state request. Link state update. Link state update packets are used to reply to link state requests and to announce new information. Link state acknowledgement. When an LSU or the link state update is received, the router sends a link state acknowledgement to confirm receipt of the link state update. Advantages. There are some advantages of OSPF, and these are the following. Changes in an OSPF network are propagated quickly. OSPF is hierarchical, using area 0 as the top as the hierarchy. OSPF is a link state algorithm. OSPF supports variable length subnet mask, or VLSM. OSPF uses multicasting within areas. After initialization, OSPF only sends updates on routing table sections which have changed. It does not send the entire routing table. Using areas, OSPF networks can be logically segmented to decrease the size of routing tables. Table size can be further reduced by using route summarization. OSPF is an open standard not related to any particular vendor. In this part, I will show you how to configure an IP address for each router's interfaces. In this topology, I am using 3 SIM routers, which is 2620XM. To configure any router, just click the router and select CLI, then followed by step-by-step commands. So first is enable in the user exec mode, then followed by configure, terminal, enter, and then interface fast Ethernet, which is 0/0, an IP address 192.168.100.1, network address which is 255.255.255.0, and then no shutdown, and then exit. Next is interface serial, which is 0/0, enter, IP address 192.168.10.1, the network address which is 255.255.255.252, the clock rate command which is 64,000, and then no shutdown, and then exit. Next is interface serial, which is 0/1, 0/1, with an IP address of 192.168.10.10, network address 255.255.255.252 because it is /30, followed by the clock rate which is 64,000, and then no shutdown, and then exit. So we're done on the first router, and then the second router. CLI, typing enable on the user exec, and then config, terminal on the global configuration mode, then interface fast Ethernet, which is 1/0, with an IP address of 192.168.150.1, network address of 255.255.255.0, followed by the no shutdown command, and then exit. Interface serial, which is 0/0, with an IP address of 192.168.10.2, then network address 255.255.255.252, followed by the no shutdown command, and then exit. Next is interface serial 0, interface serial 0/1, with an IP address of 192.168.10.5, network address 255.255.255.252. We're done on the then followed by no shutdown command, and then exit. We're done on the second router, the last router, just the same method. CLI, enable, config, terminal, interface fast Ethernet, which is 1/0 with an IP address of 192.168.200.1, the network address 255.255.255.0, and then followed by the no shutdown command, and then exit. Next is interface serial 0/0 with an IP address of 192.168.10.9, network address 255.255.255.252, followed by the no shutdown command, and then exit. And the last interface, which is serial 0/1 with an IP address of 192.168.10.6, the network address 255.255.255.252, then followed by the clock rate command, which is 64,000, then followed by the no shutdown, and then exit. So we're done. So we have done configuring an IP address in its router's interface. In this part, I will show you how to configure an OSPF routing protocol. Let's try first sending packets in designated PC. So when I'm sending packets, it is failed, failed, failed. As you can see, when I'm sending packets, the results failed, and now I'll show you how to make sending packets successful with the use of OSPF routing protocol configuration. So by typing enable in the user exec mode, followed by config terminal in the global configuration mode, then let me do first the command show IP route to be able to verify the directly connected network. As you can see, there are 3 directly connected networks, and we're going to network that with the OSPF command. So first, by typing router OSPF followed by process ID, which is 1. Process ID is locally significant and is used to differentiate between OSPF processes running on the same router. In my configuration, I am using 1 as the process ID. Then the directly connected network, which is the 192.168.10.0, then the wildcard mask 0.0.0.3. A wildcard mask is the inverse of a subnet mask, and then followed by area 1. So an OSPF area is a group of networks that shares link state information. So in this configuration, I am using 1 as their area ID. Then the network 192.168.10.8, then the wildcard mask 0.0.0.3 area 1, then the network 192.168.100.0 wildcard mask 0.0.0.25 255 area 1, and then the command default information originate. Default information originate command is used to configure a routing process to advertise a default route. So in order for OSPF to generate a default route, you must enter the default information originate command. And then exit. So we are done on the first router. Then next, the second router. Enable config terminal, then the do show IP route. Then as you can see, there's also 3 directly connected networks: router, OSPF, then the ID1, the network 192.168.10.0, wildcard mask 0.0.0.3, then area 1, network the network 192.168.10.4, then wildcard mask 0.0.0.3 area 1. Lastly, the network 192.168.150.0, wildcard mask 0.0.0.255 area 1. Then the command default information originate, then followed by exit. We have done on the second router. Lastly, on the last router, enable config terminal, the do show IP route, the router OSPF 1, network 192.168.10.4, wildcard mask 0.0.0.3, then area 1, the network 192.168 the network 192.168.10.8, wildcard mask 0.0.0.3 area 1, and then lastly the network 192.168.200.0, wildcard mask which is 0.0.0.255 area 1. Then the command default information originate, then followed by exit. So we have done configuring the router. So let's try if we can now send packets. Okay, successful. Oh, let me try. Successful. Successful. Then let me do it. Successful. Successful. So it works.